right, everyone. Let's get started with Q&A. I want to thank you guys. I want to thank both of you guys for a pretty deep technical but still accessible presentations. I'll open it up to the audience, but my first question is actually for Michael, which is, it's really interesting to see that you guys are using feature flags for setting your deployments. It's an interesting application. And I was wondering, since feature flags are oftentimes used in the services I assume that you're deploying, what kind of relationship that you might have between, say, the deployment feature flags and perhaps more business logic feature flags that are used within those services.
Right. So what's actually interesting is that we started using feature flags specifically for deployments before we actually started using feature flags for what typically people use feature flags for. So right now there's no connection. A deployment's a deployment, and then a new feature going into code with a feature flag are completely independent of each other. In fact, the cool thing about LaunchDarkly, it actually allows us to keep that separate. So we have a separate project just for deployments, and it has its own SDK key for the clients. And we have a separate one just for our user feature flags. So as of right now, we don't do that. And our typical motto is that our deployments, like we were actually never really introduced new features with a deployment. And because of that, there's, by definition, we kind of have that disconnect just by our processes themselves, that we really don't relate deployments with new features, if that makes sense.
Okay, so, interesting. Yeah, so I guess what would the process be as perhaps a developer of one of these services? I have some new code, I have it, I assume, gated by a feature flag, so I would deploy by setting the deployment, the status feature flag, and then I would go and change my actual logical feature flag within my service?
Actually, we had a really good example. So we had this big IBM conference, and we were to release a new capability. So one thing we never had before, which seems almost impossible to think about now, is that there's no way just to jump to your Kubernetes dashboard from the IBM Cloud Container Service. So we actually put this new feature in, and when we first put it in, it was hidden. No one saw it. It was hidden behind a feature flag. So we did the deployment probably about 2 weeks before it was even exposed to anyone.
Sure.
So what the developers did is the developers wrote the code with a feature flag enabled in their code for the UI, and they had rolled out that code weeks previous to the conference. And then during the conference, we could then use the feature flags to opt people in. Actually, we were opting people in by email domain at the time. So that's kind of the case where the developer did the normal process where they'd coded and pushed their code out to the environment. And then when they're ready, they use a separate project and separate project in LaunchDarkly to actually enable that feature flag for that new feature.
Interesting. Yeah, a pretty interesting process there. Hopefully, it sounds like it'll prevent quite a few outages.
It's a learning experience for us to stop, rolling out new features via deployments. So this has been really, really good for us.
Very nice. And my second question for Andrew is, so your debug process seems to be pretty efficient in being able to introspect, I guess, the logic of like stateless services. And I was wondering how it would work with, say, a stateful service or perhaps even a database.
Sure. Let's say you have a service talking to a database. We can give you TCP information on that today, so you could see how many bytes are going through, what's the throughput and all that. We don't have success rate on that kind of connection yet. If there's a need, we've actually gotten some GitHub issues for requesting Redis, for example. And so I think as there's more interest in particular protocols, we will be making the Rust proxy aware of those protocols and then be able to provide that kind of information for those connections.
Okay, very nice. Yeah, so so it seems like you guys support a variety of different transport layers. I guess what I was getting more towards is you may have some edge cases that may depend on the state of various, the various values of perhaps in your database or within your services. And depending on that state, you may trigger perhaps a few if statements or whatever, which may change the behavior that your service has and perhaps cause an error that might be emitted. Yeah,
so it's interesting. You kind of mentioned like changing behavior based on and responses and things like that. So we have an older service mesh that's much more rolled out in production called Linkerd, which allows you to kind of classify behavior of your application based on certain types of requests. So if you decide that GET requests are retryable, but POST requests are not, something like that, all of that's configurable. One of the lessons we took from that technology was that it was so configurable that kind of the answer to that was us building Conduit, which requires very little config. I think at some point down the road, we're going to have to learn how to give users the ability to control that kind of behavior depending on like how they want their app to behave.
Very nice. Okay. So let's open this up to questions from the audience. Does anybody have any questions?
Basically, because IBM, instead of one big company, it's like a million smaller companies. For example, our organization for just the IBM Cloud Container Services, our tribe is about 200 people. And that covers, product management, management, developers, support, everything like that. So when we kind of talk about this, it's really just kind of corralling those 200 people and even just a subset of developers around the process for doing that. What's kind of cool at IBM is that, being such a big company, we can actually do internal meetups. And you'll get to talk to people that are having the same experiences but didn't know how to fix it. So we've kind of been going on this dog and pony show just in IBM saying that, hey, we've got this really cool deployment process using Kubernetes and LaunchDarkly, and getting people on board to using that as well. So in fact, the process that we're doing today with LaunchDarkly and Kubernetes, we're going to start exposing it to other teams in IBM. The Watson team, that's the latest trademark that everyone's hearing from IBM. They have a huge deployment, a huge set of Kubernetes clusters. And they have the exact same problem we had, is that they've got hundreds and hundreds of deployments, and how do they manage those? So we feel we have a pretty good solution. And so we're kind of internally evangelizing this and spreading the word and getting people to use it. I've known about feature flagging for a while. In fact, my previous job before this one I'm working on right now, we had actually looked at LaunchDarkly and Optimizely. So you do a Google search for feature flags, and it's like Optimize or LaunchDarkly are right at number 1 and number 2, and I think they kind of flip daily. So there's some groups in IBM that are using Optimizely today, and we actually looked at using Optimizely for this process instead of LaunchDarkly. But what we found is that Optimizely is kind of more suited for experimentation, canary testing, things like that. You can do feature flags, but it doesn't seem to be their core offering. So then we started using LaunchDarkly, and what we really loved is just the simplicity of it, the power of it, and actually they've been really great or you guys have actually been really great for support as well. And what was interesting is that when I came to this new job, we had this deployment process, and the fact that I had used feature flags in my past job, that's kind of where that kind of mental leap of faith came into play, where users, clusters either came into play, and then we said, hey, we should use feature flags for deployments too. But now, so having said that, we've been using feature flags for deployments, and we're now just starting to using feature flags for what they're typically intended for. Trust me, we thought about this. We looked at LaunchDarkly, we were like, we could probably do this. How hard could it be? And we've actually we've learned from our past mistakes. And one of our mottos is to run, if you don't have to run it yourself, don't run it yourself. So IBM itself, it's a 100-year-old company. There's been going through some major transformations in the past few years. And one of those is actually really starting to look at smaller companies, how do they work, what makes them successful, and part of that is actually starting to, get outside of the company, start picking up existing services, because what you can find is that, using a feature flag service like LaunchDarkly, sure, we could write it ourselves, but you'd end up spending, probably a couple orders of magnitude more money just in resources and compute and storage, just all this stuff, and you probably would end up something that was not even nearly as good as what LaunchDarkly provides, because one thing we're learning is that we don't want to try to be experts in everything. We don't want to be an expert in building our own feature flag services. We don't want to figure out how to run Mongo databases. We don't want to figure out how to do all this stuff. So we're kind of passing everything off to people who actually are experts in these areas. And actually, IBM is really good about this. I mean, up until now, look, I've been putting this like $900 a month bill on my Amex card, and we finally actually getting through. Probably the biggest hurdle is actually just getting through the IBM procurement process to get a PO generated, so we can just start charging our LaunchDarkly bill and not have to submit a expense report every month for this thing. But it's been really good.
Yep. So I have another question for Andrew. You have an interesting way of essentially instrumenting services, which is it seems you're essentially wrapping these services with a proxy layer.
Yeah.
In my own work, I've also seen a lot of people moving towards essentially distributed tracing using context propagation. And I was wondering how your work compares.
Yeah, for sure. We've worked a lot with systems that leverage distributed tracing. That previous service mesh I mentioned that's still out there and in production, that has like first-class support for distributed tracing. What we found with Conduit being one of the design goals of being like zero config, to do distributed tracing well, you kind of have to instrument your app. Like you have to probably make some changes to your application code. And our thinking is that there are certain cases where distributed tracing is like, it's kind of the only tool that'll work. If you have like one very slow, long request, and you want to understand like everything it's going through and like and follow it and pinpoint what's the slow piece, distributed tracing like will give you that. Our thinking is that for like 90% of use cases, as far as like why is it slow, why is it broken, providing these tools that just kind of let you look at each hop and understand like what are the success rates and latencies between your services, we think we get you most of the way there. There's definitely been requests to add distributed tracing support into the new service mesh. We're thinking about it, but yeah.
Sure. Okay. Yeah. Very nice. Yeah. Distributed tracing is certainly gives you a lot more some certain like benefits, but is a lot more work to implement. Yep. Sounds like whereas your proxy seems to be very as you say, like zero config, so a lot easier to implement.
Yeah, that was definitely a lesson learned from Linkerd. Like we have lots of people using that, and like they start using it, and the next question is like, how do I make distributed tracing work? It's like, well, your app needs to pass headers around, and which is fine for some folks, but for others, like they want something that just works out of the box without changing anything. So it's a bit of a trade-off.
Actually, I've got a question for Andrew.
Yeah.
So we've got a lot of customers coming from financial industries, and they love encryption.
Yeah.
I mean, and what they're finding is they don't like the idea that once you kind of get past the ingress, that nothing's encrypted anymore.
Yep.
So how would you deal with something like if the pods themselves are actually exposing HTTPS endpoints?
Yeah. So so we're doing a release tomorrow, and we're doing another release in about a month, and that release will include TLS between every connection in your cluster. So the idea is that we will run like a certificate authority for you, again, like you don't do anything, and it will encrypt every connection between all of your services. Even if they're just doing HTTP1 or whatever, we'll just enable that for you if you want.
Oh. Are you selling that as a separate offering there?
Nope, it'll all be part of the open source
That's pretty
thing.
cool.
And our roadmap is on that website, and all the code's there, and all the issues are there, so have a look. It's coming soon. There are already like the work we're going to do in the next release. It's already in the design phase, and it's in GitHub issues as is. So it's there to check out. Cool. So if you have input and opinions, definitely bring it in.
Yeah. So I have another question from Michael, which is how does the observability or visibility story work with IBM Cloud? I guess, again, as a scenario, like I'm a developer, I deploy, how do I say, make sure that that the deploy is safe, that there aren't any exceptions or errors, and if there are, then is there a way for me to automatically detect it or perhaps even take action?
Yep. So we have a variety of means for that. So the first step of visibility is kind of what we showed you with the Razzie Dash, where we can just see, hey, this thing actually got deployed. Now, if there's an error during the deployment, so the cluster updater is basically saying, hey, LaunchDarkly, which version do I need to run for this particular microservice? And then it'll just apply that to Kubernetes. Now, if Kubernetes comes back and barfs and says, like, hey, you got mail from YAML, or can't connect to the API server, or whatever the issue may be, we'll actually we'll trickle it back up to the Razordash server. So it all kind of shows up there in that same view where their deployments go. Now, once it actually gets running into the environment, we do run a set of tests. For example, our stage environment and even our production environments, we do have some end-to-end tests that we run. And those test results also percolate back up to Razordash. So part of our visualization story is like, let's just push everything to this one place. I mean, from our point of view, the data is cheap. I mean, that Razordash database it's a Mongo database, and it's like 1 gigabyte. So it's kind of a drop in the bucket, considering how much value we get out of it. Now, in terms of additional logs, like the standard out, standard error, or the other log files for the pods themselves, the Cloud Container Service kind of handles that for you. So all the logs are actually forwarded to our logman service. So from you can go to a Kibana dashboard, and you can see all the logs from all your applications across all the clusters in one spot. Sure. It's a lot of data, but you can see it.
So kind of the origin story of our company is we were a bunch of infrastructure engineers from Twitter, and we all joined when the site was down like constantly, and we were involved in migrating it from like the largest Rails app on the planet to a bunch of microservices. And in doing that, we found that things like retries and backoff and telemetry and routing policy needed to be kind of centralized. We had a lot of teams that all of a sudden started building that same thing. That eventually coalesced into a library called Finagle. It's a library written in Scala. And that's what our first service mesh was built around. Linkerd wrapped Finagle. And then Conduit was kind of a lot of the lessons learned from that. But we found that application developers, you've got a lot of teams, and they may be writing in different languages, using different types of interfaces to talk to each other, and the service mesh really kind of gives like a uniform way for all of your services to communicate. That said, it's another piece in your infrastructure, right? And we're super sensitive to that. And that is a lot why we're emphasizing like zero config so much in this new one. We've had the adoption we've had with Linkerd has been great, but one of the comments is definitely like, it's a lot of work to set up. It's a lot of config that you have to learn to kind of get it to work the way you want it.
I had another question for you too.
Yeah.
So have you guys ever thought of just packages like Helm charts?
Yes, so that's an open GitHub issue as
sorry,
well right
okay,
now.
all right.
So we've had requests to have it automatically integrated with Helm. That's probably coming. It may be in the works already. So.
I did want to mention one more thing about your previous question.
Sure.
So we actually modeled kind of our visibility part and like when to deploy and when to go the next off of GitHub. So what's interesting with GitHub is that not only do they roll out code to like a small portion of their users, they will check logs, they'll check, run tests, but what's most interesting, they actually will check their Twitter feed to see if they have issues. So that's part of their kind of feedback to know when their deployment is done, is they haven't had any, people tweeting about GitHub being down.
Yep. Yeah, the good old Twitter-based debugging.
Yes.
Yeah.
We use that ourselves, for sure.
Yeah.
Thank you.
Thanks a lot.